and then we have got the input, that is A and B, and also we have to get the how many iterations are there, that is a count, and then how much of the errors we want it, that we have to take it into considerations, and then we will find the f of x, that is nothing but f of a into f of b. And then if f of x is greater than or equal to 0, then we have to stop. If it is not, then go for the second iterations, that is x old is equal to a plus b upon 2. And we'll go to the second iteration, that is I is equal to 2 there. And we'll see that the f of a, f of x is going to be f of a into the f of old. Now if f of x is equal to 0 or not, if it is s, then we take the print and then we get the values of this. If it is no, then go again whether the f of x is equal to less than 0 or not. So we will see now here, that is f of x is less than 0, and we have got the two ways to go, that is if it is s, if it is a no, then value of b will be given the value of x old, and the value of a will be given the value of x old if it is f of x is less than not equal to 0, and the values will be taken into considerations to the next step. Again, for getting the x new value, again we have to find out a plus b upon 2. That's why it is called as the iterative type of method. In this way we are going to find out the x new value again. So this is actually the new value, and again we have to find out whether the x new is going to be 0 or not. If it is s, then go for the a. That a is nothing but the soft flow chart, we will see it afterwards, remember this. And then if it is no, then we'll go for seeing the error, whether the error is going to be the permissible error, it is x new minus x old, you can say it like this, x old or x new, and then divided by x new is given to the 100, that is percentage wise if you check it, and whatever we decided the error is, this is error 1, okay, you can say, and then error 1 is if it is less than error, then go for the print, that is we got the answer what we got it. If it is no, then this will be the value where we got it, and then if it is no, then we'll go towards the flow chart of A now, the sub flow chart of A. Again calculate the value, that is compute the value, that is f of x new again, and if it is x new again, f of x new, f of x old is greater than 0, less than 0, x of old 0, 0, 1. Let us check it. If it is there, then if it is okay, if it is f of new is greater than 0, f of old is less than 0.001, then go for the print, no problem. We will get the solutions. If it is no there, then we can see that x old is equal to x new, and then is, let us see now the counter which were taken in the first. This is a counter which we have taken. If it is equal to not, if it is equal, that is I which we have taken it earlier. This is I. We have taken it. This is I which we have taken it. If it is less than or equal to the counter, then go to the C. That is C is nothing but this value. Again we have to go to this value. There the counter has been set. I is equal to 2. So we have to go here again and calculate the values for the next f of new and f of x old, and go again. If it is the counter has been equal, then stop and say that no record or no root has been found. So this is